Hi guys, it's Chris Scott with another video of electronics. The first video I made reached over a staggering 100 views, which I'm really impressed. So I'm going to explain all the electronics leading up to that project. So yeah guys, let's begin. So this can be part 1 because it's going to take too long. So yeah, I started working with circuits a few weeks ago, 1st of January. Actually no, this was actually a presentation I made for my coding club. You can check the website out. It's called Coder Doja Athlone. So if you live near Athlone and you want to learn coding and you're like 12 or 13, go join him. It's really fun. This is how I learned how to code HTML, JavaScript, CSS, and how I work with electronics. Very cool. Now I'm gonna present my. I started with simple circuits. I work my way on and on. More complicated circuits. Now I'll present my project that I made, but step by step using the Arduino. The Arduino is basically a circuit maker, coding and hardware. Step 1. Knowing what you work with. I worked with the Arduino and breadboards, also the components. The breadboard is where you can build circuits with rows and holes that allow you to connect together. So on the left you see it's plus and minus, but normally it wouldn't happen like that. Plus and minus would be together on each side. That's how I have it. That's what I have it. Yeah, let's go. So the blue lines is how they connect. It's rows. You can go to which, if you want, connecting on the rows. Pretty easy. Pretty easy to understand this, my heart. And then you have the actual breadboard, if you want to buy it on the internet, on the right side. So let's go next page. The Arduino. The first one is the USB port used. So Arduino is actually kind of complicated. This will show you step by step, numbers each part of the Arduino and see how you can use it. So the first one you see on the picture, the USB port used for powering and sending information from the computer. The second one, the power connector, is used for powering the Arduino when the USB port is not in use with the voltage. The pin ground is basically the end of circuit because it's a minus closing the circuit to the ground. 4 and 5 is the amount of voltage sending to the voltage. So 4 is 5 volts and 5 is 3.3 volts. 6, the analog pins send operating the voltage. 5 volts are 3.3 volts into integer values between 0 and 1023. So basically, you know when it's like digital, it's like 0 and 1, that's on and off. But analog, it's like basically, you imagine 0 and 1, it's like one line, but it's at 0 and 1023. It's basically like, it's like waves. And you can do you can make different options with these. It's really cool, analog. Number 10, it's number 7, I think, 7 to 9, are digital pins that can input and output information to the circuit from the microprocessor. 10, that reset button resets information in the microprocessor. So basically, the microprocessor, you code the computer in the Arduino app you can find, and then you send the information to the microprocessor that actually can store. So when you can put different times, you can store information. You can straight away do the program you want to proceed. 11 indicates that your Arduino is receiving power. 12, these LEDs indicates information sending from the computer, expected to flicker. 13, the microcontroller or the microprocessor is really the heart of the Arduino. 14 is the 5 voltage regulator, making sure the voltage is regulated to 5 volts. So guys, if that was kind of hard to explain, just pause it, just look over it, and understand how it works. Let's see next. So the components. I tell you the components I use for my project. The first one, LED, is a component that converts electrical energy into light energy. They are shorter like its cathode, minus, and they're longer like its anode, plus. So when you're putting the LEDs into the circuit or other components, they usually have plus and minus. So when you're using LED, the shorter leg, is minus, longer leg is plus. So the second is a resistor component that resists flow of the voltage in the circuit. This has many stripes, and that is numbered the voltage I resist. If the LED had too much voltage, it would burn out. So that's why you use a resistor. So when the voltage is going too much, you need a resistor to resist that voltage. So the color code shows how to calculate the resistance of flow voltage. The third one, the switch breaks the circuit when off and continue the flow when it is on. There's all kinds of switches, example push button and a simple switch. Well guys, this is going to be end of part 1. Hope you guys can go on part 2 pretty soon. Okay, so hope you subscribe, like, hit the notification bell. Hope you enjoyed it. See ya.